In building a student management system, object-oriented programming is crucial for structuring code efficiently. Classes represent entities like students and courses, while methods handle operations. Database integration ensures data persistence, allowing for storage and retrieval of student records. Graphical interfaces enhance user interaction, making the system intuitive and accessible. This approach results in a robust, scalable application. Welcome to our exploration of building a student management system using Python. We'll delve into object-oriented programming, database integration, and graphical interfaces, providing a comprehensive guide to creating real-world applications. This journey will equip you with the skills to develop scalable and efficient systems. Building a student management system allows us to apply Python object-oriented programming principles to address real-world challenges in educational settings. It provides mastery over create, read, update, delete operations, essential for data management. This system serves as an extensible foundation, ready for database integration, graphical user interface enhancement, and potential web deployment, ensuring scalability and adaptability. The student management system allows adding new student records with validation, displaying a complete roster, and searching by unique identifiers. It supports updating and deleting records with confirmation. Advanced features include a console-based interface, optional tkinter GUI, database backend for persistence, and CSV export for data portability. Core Python concepts are crucial for building robust applications. Understanding data types, control structures, and functions is essential. Mastery of these elements allows for efficient problem-solving and code optimization. Python's simplicity and readability make it an ideal choice for both beginners and experienced developers, facilitating the development of scalable and maintainable software solutions. Object-oriented programming revolves around classes and objects. Classes act as blueprints, defining attributes and methods. Objects are instances of these classes, each maintaining its own state. Encapsulation bundles data and behavior, hiding internal details. For example, a student class might have attributes like name and roll number, with methods such as display info and calculate grade. Lists offer simple iteration and maintain insertion order, making them easy to implement. However, they have ON search time, which is slower for large datasets. Dictionaries provide O1 search by student ID, efficient for large collections with direct key-based access, but require unique keys and have slightly more memory overhead. Implementing CRUD operations involves creating, reading, updating, and deleting student records efficiently. Focus on the accept method to add students. Collect user input for name, roll number, and marks. Validate data for non-empty names, unique roll numbers, and marks within 0 to 100. Create a student object and append it to the list, ensuring data integrity and efficient storage. To add students, first collect input for name, roll number, and marks. Validate the data, ensuring names are non-empty, roll numbers are unique, and marks are between 0 and 100. Create a student object with these parameters and append it to the students list. This ensures accurate and organized student data management. The display function efficiently presents student records in a structured format. It checks if the list is empty, then prints headers for name, roll no, and marks. Each student's details are displayed in aligned columns, ensuring clarity and readability. This approach enhances data presentation, making it easy to review student information at a glance. To search for a student by roll number, prompt the user for the roll number. Use a linear search to iterate through the student list, comparing roll numbers. If a match is found, display the student's details. Otherwise, inform the user that the student is not found. To update student details, first locate the student using their roll number. Display their current data, then prompt for new values, allowing users to skip updates. Validate the input before saving changes. This ensures accurate and up-to-date student records, enhancing data integrity and user satisfaction. To delete a student record, first locate the student using their roll number. Confirm their existence, then prompt for explicit confirmation before proceeding. If confirmed, remove the student from the list and provide feedback. Ensure safety by handling edge cases, like non-existent students, gracefully to maintain data integrity. Data stored in Python lists is temporary, disappearing when the program closes. Databases offer persistent storage, ensuring data survives restarts. They efficiently manage large datasets with indexing and query optimization, supporting multiple users through transaction management and locking mechanisms. This enhances scalability, performance, and reliability, crucial for robust applications. Databases overcome in-memory limitations by storing data permanently, ensuring persistence across application restarts. They efficiently manage thousands of records with indexing and query optimization, supporting scalability and performance. Additionally, databases enable multi-user access with transaction management and locking mechanisms, allowing simultaneous data modifications. Integrating MySQL with Python involves setting up a database and table using SQL. Create a database StudentDB and a students table with fields for ID, name, roll number, and marks. Establish a connection in Python using MySQL connector. Insert students with a function executing SQL queries, and retrieve data using cursor operations to manage student records efficiently. To export student data to CSV, use Python's CSV module. Define a function, export underscore to CSV, to write student details into a CSV file. This facilitates data sharing with non-technical staff, importing into spreadsheets, and creating backups. It also aids in generating administrative reports, ensuring efficient data management. Tkinter is a powerful tool for creating graphical user interfaces in Python. Labels display static text or images, while buttons trigger actions. Entry fields accept user input, and layout managers like Grid and Pack organize widgets. This setup enhances user interaction, making data management intuitive and efficient. Tkinter's GUI elements like labels, buttons, and entry fields are essential for user interaction. Labels display static text, buttons trigger actions, and entry fields accept user input. Layout managers like Grid and Pack organize these widgets efficiently. In our student management system, these components form the backbone of the interface, ensuring a seamless user experience. The student management dashboard integrates input forms with real-time validation, ensuring accurate data collection. Action buttons like Add, Update, Delete, and Search are linked to specific functions for efficient management. A tree view widget displays student records in a sortable, scrollable table, enhancing data visibility and accessibility. This setup streamlines student information handling effectively. Event binding connects button clicks to functions using the command parameter. Input validation ensures data integrity with try-except blocks and checks. User feedback is crucial. Success messages, error dialogues, and confirmation prompts guide users. For instance, validate entries before adding a student, ensuring names are present and marks are within range, providing immediate feedback. Testing and debugging are crucial for ensuring software reliability. Unit tests verify individual components, while debugging identifies and resolves issues. Use PyTest to automate tests, ensuring functions like add student and search student work correctly. Debugging tools help trace errors, improving code quality and performance. Effective testing and debugging lead to robust, error-free applications. Unit tests are crucial for verifying core functions. Using PyTest, we set up a testing framework for the student management system. We initialize test data, then test adding a student and searching for both existing and non-existent students. Run tests with PyTest Test Student Management PIV to ensure functionality and reliability. Value error occurs when converting non-numeric strings. Use try-except and validate inputs. Index error arises from accessing non-existent list indices. Check list length. Attribute error results from undefined class attributes. Ensure proper initialization. Debugging involves strategic print statements, comprehensive logging, and using Python's PDB for step-through execution. Always verify variable types with type. Let's explore a real-world demonstration of our console application. We'll launch the application, execute main.py, and navigate through the menu options. We'll add students, ensuring input validation, and demonstrate searching and updating records by roll number. Finally, we'll display all records in a formatted table and show how to delete a student with confirmation. Execute the console application by running python main.py. The menu offers options: add, display, search, update, delete, and exit. Add students by entering details, ensuring input validation. Search by roll number to update marks or name. Display all records in a formatted table. Delete a student with a confirmation prompt. Navigate the GUI by filling form fields to add students, then click Add to see confirmation and an updated table. Search records by entering a roll number, highlighting details in the table. Update information by selecting a student, modifying fields, and clicking Update. Delete students by selecting, clicking Delete, and confirming removal. We applied object-oriented programming principles, utilizing classes and objects to create a scalable architecture. Data management was achieved through create, read, update, delete operations with lists, dictionaries, and MySQL for persistence. Kinter facilitated user-friendly graphical user interface development, while quality assurance involved writing unit tests with PyTest and implementing robust exception handling. Enhance your system with an authentication system featuring user login, password hashing, and role-based access control. Develop a REST API backend for programmatic data access. Integrate a web framework like Django or Flask for a modern responsive design. Deploy to cloud platforms for global reach, and add an analytics dashboard for insightful data visualization. Explore our GitHub repository for the complete source code, detailed comments, and README. Utilize Python's official documentation and TKINTER tutorials for deeper understanding. For database integration, refer to the MySQL connector guide. Enhance testing skills with the PyTest framework. Engage during office hours or via email for project guidance. Start building your custom version today.